Okay, today's lesson topic is we are going to be learning to write equations of quadratics given certain information. But before we jump into that, we're just going to go ahead and do a quick review of graphing a quadratic, our parabola here. This is one that we should already know how to do. Looking at it, we can tell that this quadratic right here is in standard form. So this is in standard form. Okay, so if I want to graph it, first thing I'm thinking, since it's in standard form, is find my axis of symmetry. So let's go ahead and find our axis of symmetry. Our formula for that is opposite of b over 2 times a. So 8 divided by 2 times 2. So 8 divided by 4 is 2. So your axis of symmetry, remember, is the x value of your vertex. So I know that my vertex has to be 2 comma, and let's plug the 2 back in and figure out what the y value is of our vertex. So order of operations, you're going to want to make sure that you do squared first. So 2 to the second power is 4. Then multiply it by the 2, which is 8. And then you're going to subtract 16, so that's negative 8. And then you're going to subtract 24, so that's negative 32. Whoops. So my vertex is 2, negative 32. And that's definitely off our grid paper. So I guess I'm just going to label this right here. And I'm put 2, negative 32, and off to the side, and I'm going to write not to scale. And so if I can get 2 more points, then I can sketch my parabola in. So I guess I'm going to figure out y-intercept is probably not going to be enough help to figure out how to graph my parabola because the y-intercept isn't even on our grid paper either. It's 0, negative 24. Remember, to find the y-intercept, you go back to the original equation, put a 0 in for the x, and you end up with negative 24. So your y-intercept is 0, negative 24. So if we're going to find the x-intercept, it's the only thing we don't know. Remember, when you're looking for an x-intercept, you're going to let y equal 0. So I'm going to put a 0 over here, and then I'm going to go ahead and figure that out. So I'll do the work down here at the bottom of the page. So we've got 0 equals 2x squared minus 8x subtract 24. So basically we need to solve that for x, and it's a quadratic. So at this point in time, the only way you know how to solve a quadratic is by factoring or by using the technique of taking the square root of both sides. This does not look like the form to take the square root of both sides. I've got an x squared and an x, so that technique won't work. So it looks like we're going to have to try factoring. So my GCF on this is a 2. So I'll factor out the 2. And then I'll go ahead and factor the leftover quadratic here. So that's going to be x and x, 6 and 2, negative 6 and positive 2. So then that means my x-intercepts are 6, 0 and negative 2, 0. So we'll just go ahead and sketch those points in, 6, 0 and negative 2, 0. And then we'll go ahead and sketch the graph. Okay. So that one's a little bit of review. This new one is new material. So if you look closely, all I've given you are 3 points. And looking at the 3 points, it looks like these 2 points are x-intercepts, and this point is a y-intercept. All right, so when I go to write an equation of a quadratic, you're going to have to use the information given to you. We have 3 forms to write a quadratic. Remember, we have standard, vertex, and intercept. Now, based on what is given, it looks like to me I have x-intercepts and y-intercepts. Y-intercept is not super helpful in any of the forms, so I'm not really going to worry about the y-intercept. But the x-intercept is really helpful because we have a form that will help me write that. The x-intercept form is the intercept form. So that's what I'm going to use. That's how I decide which formula I want to use. I have to kind of look at what's given and how does it match our three types of forms for our quadratic. Okay, so I know I'm going to use intercept form, which looks like this. And so what we're going to do is I'm going to put in where P and Q are the x-intercepts. So I'm going to go ahead and write it like a times x minus 7 and x plus 3. Those are my two x-intercepts. So when we're doing this, guys, the trick to writing the equation is you're usually going to have an x-intercept or a vertex. What you aren't going to know is the a. You're going to have to figure out the a. If you can't just sketch it, because the problem is if I only have two x-intercepts, I don't know if my graph is really shallow. I don't, excuse me, I don't know if it opens up or down. Maybe my graph is really steep, so maybe it goes down here like this. So to get that information, you're going to have another point. You got to have at least 3 points to write the equation for a parabola, unless one of the points is your vertex. So I don't have the vertex, so I'm going to have another point. Well, I could pick any point as long as I know it's on the graph, but the only point I know that's given to me that's on the graph is the y-intercept. So for this particular graph, because the y-intercept's negative 21, I know that my graph is going to be really steep because negative 21 is clear down off my graph paper. So what we're going to have to do now is figure out what the a is that will make that work. So my the x-intercepts are kind of far apart, so we got a lot of ground to cover here on the pattern. Let's put those x-intercepts back in. 7, 1, 2, 3, 4, 5, 6, 7, and negative 3. Okay, your axis of symmetry is right here at 2. So I do know that. So I do know my vertex is 2 comma something, but unfortunately, normally we plug the 2 back into an equation. I cannot plug the 2 in over here on the left because I don't know what a is. It's not going to help me plug it in there. So what I'm going to have to do then is figure out what a is. That's the goal here. We need to figure out what a is, and you're going to use the y-intercept to do that. This is the x value, this is the y value, so I'm going to come back down here to my equation that I'm trying to write. I'm going to put negative 21 in for y. I'm going to substitute that right there. I don't know what a is, so I'm going to leave the a, and I want 0, or excuse me, the x value to be 0. All right, so now we're just going to do order of operations. And negative 7 times positive 3 is going to give you a negative 21. So basically what we found out was negative 21 equals a, or I guess we could say negative 21a because it's negative 21 multiplied by a. And if you divide by negative 21, this scenario a is 1. It's not always 1, but in this scenario it turned out to be 1. So my equation then will be y equals x subtract 7 and x plus 3. Now I can find my vertex using my axis of symmetry because now I can plug the 2 in over here to figure out what the y value is. So that's going to be a negative 25. So my vertex, once again, is off my graph paper. So 2, negative 25. And I'll just go ahead and sketch that in. Remember, try to make it curved down at the bottom, not pointed. And there's our parabola. And what's the last thing? So here's our vertex, 2, negative 25. That happens to be a min. And we've answered every question that it asked us to do. So on all of these slides, guys, the key is going to be finding A first. We got to find out what A is. We got to find out how that parabola is stretching or shrinking, or if it's staying the same. Okay, so here's another example. So write and graph the quadratic equation for the given information. Analyze what kind of information you're given. Looks like these 2 points are x-intercepts. That point is a y-intercept. So I feel like intercept form is the best form to start with. I've been given x-intercepts, so it makes sense to use intercept form. All right, my x-intercepts are at -2 and +3. And so I do know that my axis of symmetry is at 1/2. So I also know that my vertex is at 1/2. But once again, I can't figure out the y value until I know what a is. So when I plug this into my equation, so far this is what we have, x plus 2 and x subtract 3. All right, so to find the a, I've got to have another point. The y-intercept is a really useful point. It's easy to work with because one of the values is 0. It could be any point, guys, but y-intercept is definitely the easiest. So we're going to put -3 in for y. We're going to substitute that right there. A stays the same. 0 plus 2 is 2. 0 subtract 3 is -3. Okay, multiply your 2 and your -3 together, and you get -3 equals -6a. Divide by -6. So a equals 1/2. So your equation now is y equals 1/2 times x plus 2 and x subtract 3. Okay, go ahead and substitute the half in to figure out what the y value is of your vertex. And it looks like it's going to be something like a negative. If you put it in, you end up with a decimal. You could change that back to a fraction. A -3.12. So 1, 2, 3 right here. And that makes sense because my y-intercept was -3. So my axis of symmetry is really close to my y-intercept. So that makes me think my vertex is pretty close to that y-intercept also. So that looks pretty good. So now we'll just go ahead and sketch that parabola in. Okay, and then, so we've got our equation, we've graphed it, and now it says write the end behavior and the interval of increase and decrease. So remember, end behavior is talking about what are the arrows doing. So we're going to describe that, remember, in math lingo. So the end behavior would say something like the arrow on the left. So this is what we used for notation for the arrow on the left. As x goes to -infinity, the arrow is pointing up. So y is going to +infinity. And then the arrow on the right, as x goes to +infinity, it's also pointing up. So y equals +infinity. Okay, the interval of increase and decrease is describing what the graph is doing. So it looks like to me, it starts up and then it goes down here. So as I go along, I change directions at my vertex and then I start to increase again. So it looks like I start with a decrease and then I increase. So we're going to write the word decrease. And then remember, behind the word decrease, you're going to put the domain of the region where it's decreasing. And it's always right where you change direction. So it's right here on the left-hand side. All of that is where the graph is decreasing. Okay, I don't care how low it is, even though I've put this arrow down here on the vertex. I don't care about what the y value is. I care about the x value. I want that x value, the domain. So you could take and you could think, well, okay, we're going to slide everything up to the x-axis. So I kind of moved that arrow up there to the x-axis. So that's what we're looking for. The left-hand side is where it's decreasing. So that's from -infinity to a +1/2 to where the axis of symmetry is. So we're going to put -infinity to 1/2. I'll put that in a bracket. And then remember, on the other side is where we're increasing. So we want all of this region over here. So right here in the middle, guys, right there was our where the axis of symmetry was. That's where we changed directions. So we got a left-hand side region and a right-hand side region. On the left, the graph is decreasing. So that's why we put -infinity to 1/2. On the right, the graph is increasing. And what's our domain region for that? It's 1/2 to +infinity. For all the x values from 1/2 to +infinity, the graph is increasing. That's what we're saying. Okay. new idea here. So this one says write and graph the equation for the quadratic equation with the given zeros and a leading coefficient of 3. Okay, so you got to know a vocab word. So zeros, guys, is very similar to x-intercepts. A lot of times zeros are the x-intercepts. They don't have to be, but a lot of times they are. So if x equals -3 and x equals 4, because those are real numbers and they're zeros, then they actually are x-intercepts of our quadratic. And since I have x-intercepts, that makes me want to use intercept form to write my equation. The only thing I don't know is the A, but then they gave us this other piece. They didn't give us the y-intercept this time. They gave us a different piece of information. They said the leading coefficient is 3. Well, remember, the leading coefficient is the number out in front. That's where your A would be. So this has got to be 3 times x plus 3 and x subtract 4. Okay, so let's come over here and graph that. So here we are at -3. +4, and then let's find our axis of symmetry. So it looks like, once again, it's at a half. So we need to find our vertex. So our vertex is going to be a half, and now let's plug a half back into our equation. So we're going to have 3 times 3.5 times a -3.5. And that turns out to be a -36.75. So that's definitely off our graph paper. So if we want to just go ahead and put a point down here on our axis of symmetry, label it 1/2 -36.75, and then make that sketch of that parabola. And this is not to scale, so I'm just going to write that off to the side. Okay, so the domain, well, the domain of a parabola is all reals. The range is from, now if I do this in interval notation, it's always bottom to top, smallest number to biggest number, so it's a -36.75 to infinity. Remember, that's interval notation. In inequality notation, I would just say y is greater than or equal to a -36.75. That one's inequality notation. Okay, new scenario. This one says write the quadratic equation for the given information, and all I'm given is a table. So this is a bunch of points here in this table. So you kind of got to look at this table and see what you know. Right here, I see a y-intercept, but that's probably not super helpful. Our forms are standard, vertex, or intercept form, but we're talking about x-intercepts in that form, not y-intercepts. If you're having a hard time seeing anything else, I can see the vertex right here, because when I look on either side, I'm seeing the symmetry pattern happen. If you can't see that from the table, there's nothing that says you can't make a quick sketch to help you see what's happening. If you go left 4 up 5, let's say we're right there. If I go left 3 up 6, I can tell I'm a little higher. Then I go left 2 up 5 again. See how I'm even? Left 1 up 2, and then at 0, I'm down 3. I definitely can see that shape taking place. So if you need to make a sketch, make a sketch. I can also tell from the table what my A is. As these x values right here keep going over 1, that's kind of what happens in our pattern when we graph, we always go over 1. As they move over 1, look what happens with the y values. So this between a 6 and a 5 is 1. Between 6 and 5 is 1. The difference between 5 and 2 is 3. And between 2 and 3 is 5. I can see it's following my 1, 3, 5 pattern. So I can see that this parabola has an a value of -1. It's opening down. It's following the 1, 3, 5 pattern. I'm going to use vertex form on this one because I have the vertex. I don't have any x-intercepts. The x-intercept right here is some kind of decimal value. I don't know what it is, so I think it makes sense to use vertex form. So I'm going to say y equals a -1. I'll just write the negative sign. X plus 3 quantity squared plus 6. There's our equation right there. That's vertex form. Okay, new scenario. This time I give you a graph. So I'm looking at it, and I can tell what the y-intercept is right here. That is 0, 2. I'm looking at the x-intercepts, not really sure what they are. Those are probably some kind of a decimal or a fraction or maybe a radical, I don't know. But I can tell what the vertex is. So the vertex is 4, -6. So I feel like vertex form would be the best option. So y equals a times x minus 4 quantity squared subtract 6. So we need to figure out what a is. If we can count it out on our graph paper, let's do it. If I go up 1 over 1, up 3 over 1, it doesn't match. A is not 1. It's not following a 1, 3, 5 pattern. So now it's either got, and it looks like it was flatter than it should be, so I think the a should be a fraction. So if I go up a half over 1, okay, that looks good. That looks like that probably matched. Up 1.5 over 1, you can see you landed right on a grid mark. So a is a half. Okay, what if it turned out to be something really close to a half, and you weren't quite sure if it was matching up on grid marks? You could still do it algebraically like we did with the x-intercept. Come back here to your y equals a times x minus 4 quantity squared, subtract 6. Let's use the y-intercept. All we got to have is another point, guys, to plug into your equation. Y-intercept is easy. You could pick another point on a grid mark. I could pick this one if I wanted. I could pick, what is that? 1, 2, 3, 4, 5, 6, 7, 8, 2. I could put 8, 2 in if I wanted to find a. But let's use something with a 0. A 0 is easy to work with. So we'll put in 2 right here for y, 0 for the x. So a -4 raised to the second power is 16. So what you have to be careful with, guys, is your order of operations right here. This 6 has nothing to do with that parenthesis. Like you wouldn't take 16 and subtract 6 from it. This piece right here is all one piece, and you need to work with it as one piece. So I think if you don't want to get confused, add the 6 to the other side. So 8 equals a times 16. So that's 16a. So 8 equals 16a. Divide by 16. So a is 1/2. And you could still get the 1/2 like we had before. So that will still work. You can do it algebraically, or if you can count it out on your graph paper, that works also. Okay, here's the last one. Write the quadratic. Now I'm looking at this, and it looks like to me I see x-intercepts. I see a vertex, and it looks like it goes down 1 over 1, down 3 over 1, down 5 over 1. So it looks like to me we're following our 1, 3, 5 pattern. It's going down, so my a is a -1. So I could say y equals negative. I could do vertex form. X minus 0 quantity squared plus 4. Well, we don't write x minus 0, so we just say y equals -x squared plus 4. I could do that form. Or I could have done intercept form since I know the two x-intercepts, and I could put the negative sign and go x plus 2 and x minus 2. Both work. So what you guys have got to be able to do on writing your equations, determine most of it's really going to be either vertex form or intercept form. You just got to figure out what the a is. That's the key. Find what the a is.